Hello, this is Dr. Hanaa Assil, and this is paper 3 of June 2017. This is version 1 from the IGCSE Chemistry, Cambridge. So let's take a look at the questions. The first question has different atoms, and he has the electronic structures of these atoms, and he's saying which atom has a complete outer shell of electrons. Of course, I look through this and I see which one in the outermost shell there are a total of 8 electrons. Of course, the one that has 8 electrons in its outer shell is A. So remember that A would be, if he's saying which group it is, it would be in group 0 or group 8. So this is obviously a noble gas. Which one has proton number 15? When he says proton number 15, that means that it has 15 protons, and that means it also has 15 electrons. 15 electrons means they will be distributed 2 in the first shell, 8 in the second shell, and 5 in the outermost shell. So which of these has 2, 8, 5? That would be E. Which one has 4 shells? So you should have 4 circles around the nucleus, 4 energy levels around the nucleus. Of course, C has 4 energy levels. Which one is fluorine atom? Now, if we look at the periodic table will tell us that fluorine has an atomic number of 9, a small number of 9. So 9, atomic number 9 means it has 9 protons and it has 9 electrons. 9 electrons would be distributed 2 in the first shell and 7 in the second shell. So which one has 2, 7 in the electronic structure? That is B. Which one is an atom of a metallic element? How do I know if it's a metal? We said metals are in group 1, 2, or 3. So they must have 1 or 2 or 3 electrons in their outermost shell. So which one has 1 or 2 or 3 electrons in the outer shell? So that is C. C has 1 electron, so it's obviously in group 1, and that means it is a metal. The next part of the question says, complete the table to show number of electrons, neutrons, protons in the chlorine atom and in the bromide ion. So number of electrons. How do we know the number of electrons? Number of electrons originally is the small number or the atomic number. So chlorine has atomic number 17. That means it has 17 electrons. Now what about Br minus? Well, the atomic number of bromine is 35. That means originally it has 35 protons and 35 electrons. But the Br has an extra negative charge. This is Br minus. This is bromide ion, and that means it has an extra electron. So instead of having 35 electrons, it would have 36. What about number of neutrons? How do we get the number of neutrons? Remember that the number of neutrons is mass number minus atomic number. The big number minus the small number. So here it is 35 minus 17. So chlorine has 18 neutrons. What about the number of protons? You should remember the number of protons is always the small number, or what we call atomic number. So chlorine has 17 protons. Bromide ion, Br minus, has 35 protons. Remember, the number of protons does not change. If the ion has positive or negative on it, it is only the number of electrons that will change. Number of neutrons, number of protons will not change for the atom and the ion. Question 2 says the table shows the ions present in 1000 centimeter cubed sample of polluted river water. So we have a total solution of 1000 centimeter cubed. and he measured how much calcium, how much chloride, how much hydrogen carbonate, and so on. Now answer these questions using information from the table. Which positive ion is present in the highest concentration? So first of all, I'm looking at the ones that have positive charge, like calcium, magnesium, potassium, sodium. Now, which of these has highest concentration? So which one has the highest mass in the 1,000 centimeter cubed? Of course, the Na. Na plus is the one that has more mass in milligram per 1,000 centimeter cubed. State the name of the ion SO3 2 minus. SO3 2 minus is called sulfite ion. Remember that SO4 is sulfate. SO3 is sulfite. And remember, this is SO3 2 negative, not just SO3, because if it is just SO3, that would be sulfur trioxide. But SO3 2 minus is the sulfite ion. Calculate the mass of silicate ions present in 250 centimeter cubed. Well, the table shows you how much in 1,000 centimeter cubed. So where is the silicate? The silicate is 12 milligrams in 1,000. He wants how much in 250? So just straightforward cross multiplication would give you 3 milligrams. Calculate the mass of solid formed when all the water is evaporated from the 1,000 centimeter cubed sample. So these are the solids that are dissolved in the water, calcium ions, chloride ions, and so on. So he wants the total mass of the solid when all the water is evaporated from the solution. So of course, if we evaporate the water, we're left with all these ions. So you're just adding up all of these ions. So that is 36.3 milligram when you sit down and add all of these milligrams in the 1,000 centimeter cube. Name the compound containing Ca2 plus and HCO3 minus. Well, Ca2 plus is calcium ion. So this is calcium something. Now, what is HCO3 minus? Well, get it from the table. He wrote the name of that. That is hydrogen carbonate. So the compound would be calcium hydrogen carbonate. Describe a test for sodium ions. What is the test that we have for sodium ions? The test that we have for sodium ions is flame tests. Do you remember the flame tests? You're required to know the colors for all of these. And remember that barium is a new addition to the syllabus for 2023. So you should know these colors. Now, which one is sodium? You should realize that sodium gives a yellow flame. And please learn these colors. The formula of some chlorides are given. Deduce the formula of magnesium chloride. Remember that when we put the formula of something, we write the symbols and then we put the valency of one under the other. So if I'm writing magnesium chloride, I'm going to write the symbols. If you look at the periodic table, magnesium is in group 2, so its valency is 2. So the 2 goes under the chlorine. Now, chlorine is in group 7. That means it has valency 1, and that means I'm not going to write anything under the Mg. So the formula for magnesium chloride is MgCl2. Molten calcium chloride can be electrolyzed using inert electrodes. So we're doing electrolysis of molten calcium chloride, and he's asking what is the product at the negative and what is the product at the positive. Okay, first of all, molten calcium chloride. What are the ions that we have? We said the first one is positive, the second one is negative. So calcium, of course, is something in group 2. When it forms ions, it loses the 2 electrons, so calcium is 2 plus. And chlorine is in group 7. When it forms an ion, it gains 1 electron, so this is Cl minus. So my ions are Ca2 plus and Cl minus. Now, which one goes to the negative? Remember that the positive ions are the ones that go to the negative. If you're not sure which one is positive and which one is negative, the first one is always positive, so the calcium would be positive. The chloride ion would be the negative. So the positive calcium ions will go to the negative electrode and do what? Take electrons and become calcium metal. So what is formed at the negative is calcium metal. Now, the positive electrode, the Cl minus is the one that will go to it, and negative ions go to the positive electrode to lose electrons, to give electrons. And that forms chlorine gas. Please note that the product at the positive is chlorine, not chloride. As an ion in the solution, it is chloride ion. But when it reacts, what is formed at the positive is chlorine molecule or chlorine atoms, not chloride. The diagram shows part of the structures of 3 substances, X, Y, and Z, at room temperature and pressure. Describe substances X, Y, and Z in terms of their bonding, arrangement of particles, and motion of particles. Okay, let's look at X, for example. What is the bonding in X? X is carbon dioxide. It has double covalent bond, so the bonding is covalent. What about Y? Y has positive and negative ions. Anything that has positive and negative ions is an ionic compound with ionic bonds. What about Z? You should recognize that Z is the structure of diamond. And diamond is made up of carbon atoms with covalent bonds between them. So if we're talking about bonding, we're going to say that X and Z have covalent bonds, while Y has ionic bonds. Now, arrangement of particles. Obviously, you can see that X is a gas. So how are the particles arranged? If it's a gas, the molecules are far apart, randomly arranged. What about Y and Z? Y and Z are giant structures. Y has ionic crystals in regular rows, while Z is a giant three-dimensional tetrahedral structure. What about motion of their particles? How do the particles in X move? X is a gas. How do the particles of a gas move? They move fast, freely, random motion. Y and Z are solids. Sodium chloride, ionic compound, is a solid. Diamond is a solid. So if we say how do the molecules move, they vibrate in fixed position. A closed gas syringe contains substance X. Describe what happens to the volume of substance X in the syringe when the pressure is increased. Remember, if I am increasing the pressure, that means I'm pushing that plunger of the gas syringe in. I am pressing on the gas. What would happen to the volume inside the syringe? You should realize that when we press a gas together, that is what we mean by increasing the pressure. When we increase the pressure, the volume gets smaller because the particles get closer together. And remember, we said we can do that only for gases, because solids and liquids, the particles are already close together. So I cannot push them further, closer together. But gases, because the particles are originally far apart, then when we increase the pressure, then they come nearer to each other and the volume gets small. Substance Z is diamond. Diamond is used in jewelry. So you should recognize that this is the structure of diamond. And if you were to ask me, describe the structure of diamond, do you know how to describe the structure of diamond? We should say giant three-dimensional tetrahedral structure in which each carbon atom is covalently bonded to 4 other carbon atoms. So that is if he says describe the structure. But he's saying what? He's saying give one use of diamond. Remember, what do we use diamond for? We don't say jewelry. So if he asks me name one use of diamond, I shouldn't say jewelry. He says that we use it in jewelry. Good. What is another use of diamond? We use diamond for cutting and drilling. We know that diamond is very hard and we use it for cutting, like cutting things like glass, or drilling. Drilling means cutting through metals or cutting through solids. Substance Y undergoes physical and chemical changes. Substance Y, if you remember, substance Y was an ionic compound, sodium chloride. Which two of the following are physical changes? So he's asking which of these are physical changes. We have substance Y dissolves in water. Aqueous solution of Y gives a white precipitate with acidified aqueous silver nitrate. Substance Y melts at 101. Substance Y reacts with concentrated sulfuric acid. Remember that a physical change is what? A physical change is one in which no new substance is made and it can be reversed. So it is not a chemical reaction. If he's talking about a chemical reaction, reaction of something with something to give something new, that is a chemical change. But when I am changing a substance from one state to another, for example, dissolving in water or melting from solid to liquid, then A and C are physical changes. This is because when you dissolve something in water, you're forming a mixture. It's not a chemical reaction. And when you heat to melt, you're just changing the solid to liquid. And this can be reversed. You can get back your solid from the water, or you can freeze back your solid. And there is no new substance formed. It is the same substance that you started with. While B and D are chemical reactions. So we cannot call them a physical change. Chlorine is an element in group. Group, what is this? You should be able to read these Roman numerals. The V represents 5, and any number after it is added to the 5. So this is 5 plus 2, so this is group 7. Group 7 of the periodic table. Chlorine is a diatomic molecule. Explain what is meant by the term diatomic. When we say that halogens are diatomic, which ones are diatomic? Halogens are diatomic. Hydrogen, nitrogen, oxygen, all of these are diatomic molecules. When we say that something is diatomic, that means that the molecule is made up of 2 atoms. You have to have 2 atoms bonded together to form a molecule. So this is what we mean by diatomic. Aqueous chlorine reacts with aqueous potassium bromide. How does this equation show that chlorine is more reactive than bromine? Remember that if I'm reacting chlorine with potassium bromide, the chlorine has displaced the bromine, or it pushed the bromine out and sat in its place, figuratively speaking. So if something displaces another one, then that one is more reactive. Chlorine was able to displace bromine. That means chlorine is more reactive. So why am I saying it's more reactive? Because it displaced the bromine. Aqueous potassium bromide and aqueous potassium chloride are both colorless. Predict the color change when aqueous chlorine reacts with aqueous potassium bromide. You can see from the equation up there, if I pass aqueous chlorine or I add aqueous chlorine to aqueous potassium bromide, the potassium bromide originally is colorless, but when it reacts, it forms bromine. And you should realize that bromine in solution is orange, or what we call reddish brown. So the solution changes from colorless to reddish brown or orange. Complete the chemical equation for the reaction of bromine with aqueous potassium iodide. Of course, bromine can react with potassium iodide because bromine is more reactive than iodine, so it can displace it. So what will it give? It will give iodine plus potassium bromide, and you need to balance that, so you put a 2 in front of the KBR. Please do not leave any equations without balancing. If it's a chemical equation, symbol equation, it has to be balanced. Describe a test for iodide ions. What is the test for iodide? Remember, what do we add? We add nitric acid and silver nitrate solution. Silver nitrate, acidified silver nitrate, is a test for the halides, chloride, bromide, iodide. If I'm testing for any of these, I add dilute nitric acid and silver nitrate solution. If I had chloride, it would give me white precipitate. Bromide, cream precipitate. Iodide is yellow precipitate. Chlorine is used to make the polymer PVC. Give one other use of chlorine. Do you know the uses of chlorine gas? What do we use chlorine gas for? To kill bacteria in something. So to kill bacteria in drinking water or to kill bacteria in swimming pools. The monomer used to make PVC is made by thermal decomposition of dichloroethane. So it's giving me an equation. What is meant by thermal decomposition? You should know. The type of reaction called thermal decomposition, what does that mean? Breakdown of a compound using heat. Thermal decomposition is breakdown of a compound using heat. PVC is a non-biodegradable plastic. Describe 2 pollution problems caused by non-biodegradable plastics. First of all, if you were to ask what do we mean by non-biodegradable? You should know non-biodegradable means it is not broken down by bacteria. So we say that normally or most of the plastics are non-biodegradable, and that means they cannot be broken down by bacteria. Now, what kind of problems would that cause? Well, if we throw them into the dump sites, they are not broken down, they remain there, so they accumulate in dump sites. And then when we decide to burn them, it produces toxic gases. Okay, so the disadvantages or the problems of plastics. They are non-biodegradable, so they accumulate in dump sites. And when burned, they produce toxic gases. The structure of citronellol is shown. On the structure shown, draw a circle around the alcohol functional group. Which part of the molecule indicates that this is an alcohol? Remember, alcohols must have what? Alcohols must have OH, so this is the functional group of alcohol. How many hydrogen atoms are there in one molecule of this compound? Well, sit down and calculate all of this. 3 plus 3 plus 2 plus 2 plus 3 plus 1 plus 2 plus 2 plus 1. So the total number of hydrogen atoms, if you count them, is 20. What feature of this compound shows that it is unsaturated? What do we mean by unsaturated when we're talking about organic chemistry? We said unsaturated compound means it has C double bond C. Don't just say it has double bond. It has to be a double bond between carbon atoms or C double bond C. That indicates that it is an alkene, and alkenes are unsaturated. The table shows the properties of some alkanes. Describe how the density of the liquid alkanes varies with number of carbon atoms in one molecule. So he's talking about the density. Can you see where the density and the number of carbon atoms? So we have number of carbon atoms, 1, 2, 3, 4, 5, and we look at the density. So as the number of carbon atoms increases, what happens to the density? Well, you can see density increases as the number of carbon atoms increases. Predict the boiling point of propane. Where is propane? When we have this kind of question, you should realize that the boiling point of propane is somewhere between butane and ethane. Minus 162, methane has minus 162 boiling point. Ethane has increased by about what? By about 80. That means the increase, and then from 0, butane is 0, 20 to 36 in pentane, so it increased by about 36. So that means that you need to increase from minus 88 by about what? By about 40, for example. So I would say minus 40 degrees Celsius. Actually, any number in between 0 and minus 88 would be accepted. Why would it be difficult to predict the melting point of butane from the information in the table? Well, let's take a look. What's happening with the melting point? From methane to ethane, it decreased. From ethane to propane, again, it decreased. But then if we look at pentane, it increased. From propane to pentane, it increased. So I don't know from propane to butane, would it increase or decrease? This is because there is no clear trend. Okay? What is the state of pentane at 30 degrees Celsius? Well, let's take a look. Where is pentane? At 30 degrees Celsius, he's telling me that the melting point of pentane is minus 130. The boiling point is 36. So what is it at 30 degrees Celsius? You can see that at 30 degrees Celsius, the melting point is low. And that means by 30 degrees, it has melted. But it hasn't boiled yet because the boiling point is higher than that. So at 30, it is a liquid since its melting point is below 30 and the boiling point is above 30. Alkanes are hydrocarbons. What is the meaning of the term hydrocarbon? You should know the meaning of hydrocarbon. Hydrocarbon means organic compound having carbon and hydrogen only. Please do not forget the word only, because all organic compounds have carbon and hydrogen. But if there is nothing else, then it's a hydrocarbon. Draw the structure of ethane. How do we draw the structure of an organic compound? You first ask yourself, how many carbons? F means 2 carbons. Remember, meth, F, prop, bute, pent. Meth is 1 carbon, F is 2 carbons, and this is an alkane, so it has a single bond between the carbons, and then you complete. Each carbon must have a total of 4 bonds. So if it is making 1 bond with the next carbon, then it needs 3 more bonds to hydrogens to complete the structure. So this is ethane. Complete the chemical equation for combustion of propane. So basically you're trying to balance here. You have how many carbons before the arrow? We have C3, so we have 3 carbons before the arrow. That means that I need to put what? I need to put 3 in front of the CO2. Then we have hydrogen is 8 before the arrow, so he has 2 times 4, that's 8. Now, how many oxygens after the arrow? We have 2 times 3, that's 6. Plus 4, that's 10. So I need a 5 in front of the O2 so that we have 10 oxygen atoms before the arrow. You should know how to balance. Okay, the table shows the properties of some metals. Which metal would be most useful for making overhead power cables? So we look at the choices. What do I want in overhead power cables? First of all, I need it to have good electrical conductivity. That means I would choose something like aluminium or silver or tungsten. We're not going to choose silver because silver is very expensive. So our choice is aluminium or tungsten. Now, what else do I need in overhead power cables? Well, I need it to be low density. So I need something that is light, low density. So in that case, we're going to choose, if you look at the density, aluminium will have lower density. So the reason why I'm choosing aluminium is it has low density and it has high electrical conductivity. Why is iron and not tungsten used to reinforce concrete? Reinforce concrete means I want to make it strong. So I need something that is strong. So he's saying iron and not tungsten. Where is iron and tungsten? We're looking at the strength. Iron is 21 and tungsten is 12. So obviously this is because iron has higher strength. Then he says the front part of a space rocket is called a nose cone. The nose cone gets very hot as the space rocket moves through the air. Which metal is best to make the space rocket nose cone? So this is something that is going to be very, very hot. So I need it to have what? I need it to have high melting point. I don't want it to melt in the heat. So I'm looking at which one has high melting point. So that is tungsten. Remember, he's saying explain your answer. This is because it has very high melting point. Tungsten is a transition element. State two physical properties. Please remember, you need to talk about physical, not chemical, of transition elements which are not shown by group 1 elements. So what are the physical properties that identify transition elements? You should realize that transition elements would, compared to group 1, it would be hard because we said group 1 are soft metals. Group 1 have high melting point, high density, more than group 1. So these are the physical properties. Don't say they form colored compounds. That's not physical, that's chemical. Don't say they may act as catalysts. That's not physical, that's chemical. Okay? Pay attention. What is he looking for in the question? When extremely hot tungsten reacts with oxygen, an oxide is formed. Balance the equation. So obviously, how many tungsten is the W? If you look at the periodic table, the symbol for tungsten is W. So how many tungsten after the arrow? I have 2, so I need to put 2 before the arrow. How many oxygens after the arrow? You should realize that I have 2 times 3. So before the arrow, I will also need 2 times 3. Some information about the reaction of 4 metals with oxygen is given. List these metals in order of reactivity. Put the least metal first, the least reactive first. Please note when he tells you to arrange things in order, is he starting with the least or with the most? So let's look at what he tells me. I have cobalt reacts slowly. Iron burns when heated strongly. Magnesium burns when heated. So I don't need to heat it strongly. Tungsten reacts very slowly. So which one is least reactive? I have reacts slowly and reacts very slowly. So the one that reacts very slowly is the least reactive. Then the one that reacts slowly. And then the one that burns when heated strongly. And then the one that burns when just heated, immediately it will burn. That will be the most reactive. Okay? The table compares the time taken for reaction of an alloy with ethanoic acid, nitric acid, and phosphoric acid, each at 3 different concentrations. The time taken for the alloy to decrease in mass by 1 gram was measured. All other conditions were kept the same. So he's measuring time, first of all, and he's changing concentration of acid, and he's using 3 different types of acid. How does concentration of acid affect the rate? So in that case, we want to look at one of the acids. So let's say ethanol. What does the concentration affect the rate? Well, at 0.04, the time was 92. Remember, rate means if something is faster, it takes more time or less time. If something is faster, it takes less time. So if we're looking at ethanoic, for example, at 0.04 concentration, it took 92 hours. At lower concentration, it took more and more time. That means slower rate, and that means at higher concentration, the rate is faster. Which acid reacts most rapidly with the alloy? Most rapidly means faster, means it takes less time. So which acid took less time for reaction? Of course, that is the nitric acid. Predict how long it would take for the alloy to decrease in mass by 1 gram using phosphoric acid of concentration 0.03. Where is phosphoric acid? So he used concentration 0.04, 0.02 and 0.01. So if he's using 0.03, it is somewhere in between the 19 and 39. So let's say 29 hours. So this is an estimation, somewhere in between. So just which one of these pH values is the pH of concentrated aqueous ethanoic acid? You should be familiar with pHs of some of the substances that we deal with. So, for example, you should know that strong acids like hydrochloric acid, sulfuric acid, nitric acid, these would have pHs 1 or 2 or 3. Something that like ethanoic acid or vinegar or lemon juice, all of these are weak acids, and weak acids would have pH 4 or 5 or 6. You should know that water is neutral. Salts like sodium chloride are neutral, and that means pH 7. Weak bases like ammonia are the ones that would have pH 8 or 9 or 10. A strong base like sodium hydroxide, calcium hydroxide is the one that would have pH 13. So remember that ethanoic acid would have pH 4, 5, or 6, whether it is concentrated or dilute. So the fact that it's concentrated doesn't mean it's going to have a pH of 1. That's not right. Okay. Question 7 talks about carbon. Carbon is an element in group 4 of the periodic table. It reacts with oxygen to form carbon dioxide. The energy level diagram for this reaction is shown. Explain how this diagram shows that the reaction is exothermic. First of all, what do we mean by exothermic reaction? You should know that exothermic means a reaction that gives out heat, or the reactants will lose some of their heat, and that means the products will have lower energy than reactants. So this shows that it is exothermic because the products have lower energy than reactants. If this were endothermic, then the products would be up above the reactants. Carbon monoxide, carbon dioxide, and methane are all atmospheric pollutants. Give the sources of these gases, describe the effects of both carbon dioxide and methane on environment, and state the adverse effect or the bad effect of carbon monoxide on health. So let's see, what are the sources of these gases? You should know the source of each of these. Carbon monoxide is produced by incomplete combustion of fuel. And remember, incomplete combustion of fuel means burning in lack of oxygen or burning in less oxygen. So carbon monoxide is produced by incomplete combustion of fuel. carbon dioxide is produced from complete combustion of fuel. That means burning in excess oxygen or burning in a lot of oxygen. Methane is obtained from what? Decomposition of vegetation or digestive system in animals, from the digestion in animals. Now he wants effects of carbon dioxide and methane on the environment. You should know that carbon dioxide and methane are greenhouse gases that cause global warming, climate change. This leads to the melting of the ice and flooding. So these are the effects of carbon dioxide and methane. The adverse effect of carbon monoxide on health is the fact that it is toxic or poisonous. Calcium carbonate decomposes to form calcium oxide and carbon dioxide. State one use of calcium oxide. You should know that calcium oxide is a base, so we use it to neutralize anything that's acidic. For example, we use it in neutralizing soil acidity, or we could say we use it in neutralizing acidic waste in industry. So a use for calcium oxide is neutralizing solid soil acidity. Calculate the relative formula mass of calcium carbonate. How do we calculate relative formula mass? Relative formula mass is the same as what we call molecular mass. So that is the MR. How do we calculate MR of calcium carbonate? You look at the periodic table and you choose what? The big number or the small number? To calculate mass, formula mass, or molecular mass, or MR, you're using the mass number, which is the big number. So mass number of calcium is 40. I have one of them. Mass number of carbon is 12, and I have one of it. And mass number of oxygen is 16, and I have three of them. The total makes up 100. That is my relative formula mass. Carbon and magnesium are both insoluble in water. Carbon does not react with hydrochloric acid, but magnesium reacts to form a soluble salt. That means magnesium will dissolve in acid, carbon will not. And when it dissolves, it forms a soluble salt and a gas. Of course, magnesium with acid will form the salt and hydrogen gas, which escapes into the air. So just how you could prepare a pure dry sample of carbon from a mixture of carbon and magnesium. So he's given me a mixture already mixed of carbon and magnesium. Don't say add carbon to magnesium. We already have a mixture of carbon and magnesium, and we're trying to get what from it? We're trying to get carbon. So what should we do? We have carbon and magnesium, and he's telling me the carbon will not dissolve in acid, but magnesium will dissolve in acid. And that means that the first thing I should do is add a certain acid. He's saying hydrochloric acid to the mixture in a beaker and stir. Of course, I can say stir with a glass rod. And then when I do that, the magnesium dissolves and I'm left with the carbon at the bottom of the beaker. So how do I get the carbon? I filter through filter paper and funnel. The carbon is collected as residue. Then he wants pure dry sample. So I have to say wash the residue with a few drops of distilled water, dry between filter papers. Okay, and that's the end of this paper. You can share the video with your friends, and thank you for listening.